Let me start by explaining what the persistent identification of instrument working group is and what we did. So the goal is this working group seeks to explore community-driven solution for globally unique identification of measuring instruments operated in the science. So the idea is to attribute PIDs for instruments, which may be useful to better track the scientific output of an instrument by journal articles and data sets being able to reference that instrument. And at the same time, that will enrich the metadata of data sets if information about the instrument can be retrieved. And we believe that instruments are just another node in the PID graph that needs to be established. So the working group has already finished its normal lifespan of an RDA working group. And what we did in that time is we collected use cases from various institutions interested in using PIDs for instruments. We formulated a metadata schema to describe instruments and for the PID metadata. And we explored potential implementations with PID infrastructure providers, and we tried out EPIC candidates and dataset DOIs. And we produced some outputs. So we have a journal article in Data Science Journal, which basically summarize the activities of the group. And we also have a so-called PIDINST white paper, which is more like a technical description or a manual on how to do all that. And so this white paper we are about to submit that to RDA review as a supporting output. And the working group is now in maintenance mode. That means we are still working on the results and maintaining them and considering adoption. And that is also one of the topics of this session. So, Martin, do you want to continue with the moderation?
By Martin, you mean Marcus or?
Marcus, sorry.
Yeah, no problem. Confusing, right? Good. I always need to switch my feed camera source here. Good. Yeah, thanks, Rolf, for the introduction. Perhaps we are a small group here, so perhaps we can take some questions if they are at this point. I just highlight also again there is a Google Docs in the chat. You could open that also and at least mark your presence in the participant list at the top, and then if you have spare capacity while listening, you can also take some notes or also post some questions there. That's also a possibility. I will try to keep an eye on that. Thanks, Patricia, for sharing the notes. I guess it's not visible to the people who join later, so that's great. Good. I don't see any questions at this point, so perhaps we can move to our first speaker, which is a little bit different order to what we had in the agenda, because today we have only very few speakers compared to live speakers compared to the session Tuesday. So we have recorded all the sessions from Tuesday, and we are going to play them today. And hopefully we will have a little bit more time in the end for some questions and discussions. I see also Shoban just joined, so perhaps we can also have a little bit more discussion on the I4IS or I4IOS PIDINST working group relation. Great. So then, that said, I would just pass on to Sven then for his live talk.
Everybody, let's just share my screen. So as last time, I don't see if I really shared something. Can you see the slides? Yes.
We do.
Okay,
yes.
Perfect. That was fast in comparison to last time. Okay, let's give me a short introduction to what we do in our project to adopt the PIDINST schema. The project is done within a EU project called Open Forecast, where we try to manage open data, especially data from a sensor community network. So give me a short introduction to this data we actually have, or the sensors, or the instruments we have to look at. Sensor community is a citizen science project where you can get for quite low money a sensor, attach it to your house as a private person, and contribute with the data measured by the sensor to a larger network. As you can see on the map, there's already thousands of sensors available in Germany and in nearby countries and spread all over the world. As I said, it's a really fun project. Typically measured is air pollution, or specifically fine dust or particulate matter. But there's also sensors for other types like noise or radiation. This is how it looks like. Typically, this is our instrument. It's a bit funny in comparison to more complex instruments in this working group or in the use cases. It's a very simple, low-budget sensor. This is a typical one for measuring air pollution and temperature and humidity. And we have thousands of those, and you have already millions of data points. And with this project, we would like to support the community by improving the visibility of the sensors, of the data, and make it more accessible. And with that, we would like to assign PIDs to the sensors. We came up with a very complex background infrastructure to collect the data, first of all, from the central data archive, and transform the data into different other databases like time series databases, graph databases, and so on. And now we are working out on a PID database, so to say, how we can get this into a PID database. As I said, it's very complex. We have about 24 different sensor types like temperature, humidity, and so on, spread over about 1,700 stations, and each station could contain 2 or more sensors. In total, about 30,000 sensors measuring 29 different variables. That could also be that temperature is measured in Kelvin or in Celsius, but typically is we have one measurement variable for each quantity. What we do have, so to say, is basically the raw data. We have some kind of a sensor ID where the data is coming from. We have the geo coordinates. We have the value, and typically we also have some kind of a name of the sensor, what kind of sensor it is. It's a abbreviation like PN 29, whatever, saying this is a typical temperature measurement. This is all we have basically, and with this minimal data set, we try to apply the PIDINST schema, where we need to have actually much more data, much more information, like who's the owner, what is the manufacturer, and so on. That means based on our given schema or graph schema, whatever we have, we try to adopt this PIDINST schema, and we're quite active and successful, I would say. We use the EPIC Persistent Identifier Consortium. We have our own prefix where we can store the 20,000 sensors or PIDs, 30,000 sensors. But we do have to do still quite a lot of manual work. So we try to automate as much as possible. So, but stuff like who is the manufacturer? Manufacturer is something we can only guess from the data and have to look up in the internet about more details about the sensor. So what's the actual manufacturer name, the production date, model type, and so on. But it's somehow possible. Of course, we also have to do data cleaning and data correction. And one issue we have when we showed this example to the community, say, yeah, but we have to look at the privacy constraints. So not everybody wants to have his or her name assigned to a location in his or her country. Yeah, so we have different regulations in different countries. Just remember, we have sensors all over the world where people try to contribute with air quality measurements or other measurements like radiation and so on. So here you can see an example of an PID, which is resolved via HDL-handle.net. It's a handle-based APIC PID with the data, and you can see in line 7 the typical hand curated data, like the manufacturer is Asong Electronics Co. Ltd. It's typical producer for this temperature sensor. Other sensors from Bosch or whatever. Okay. We have still some issues with the landing page. We currently refer to the sensor.community main page, but we would like to build up, of course, a landing page where we can show the data nicely and also allow users to actually assign him or herself to the sensor by saying, I own the sensor and I'm proud of, and I would like to get the credit. So I put my name into the database as a owner. Then the owner would switch from the community into the person owning the sensor itself. So this is one of the next steps to say what is missing. We have a fully automated backend going through every night all the data we get. It's, as I said, it's thousands of data points and thousands of sensors. We have statistics. We have templates for manufacturer and other things. And what is missing is still the website to present and allow additional information to our PID instrument thing. Yeah, we will distribute this more into the community and hope that with this tool, people can search for sensors and retrieve data to do nice analysis with the thousands of data points in future. And next step to do, of course, is also for you, get a sensor and join the community. Thank you very much.
Yes, thank you, Sven. Any quick question? I have one. How do I get the sensor?
On the website of sensor.community, it's really called sensor.community is the website, right? And there's a link in the chat where you can go and they give you some hints. Most of us actually go to these Chinese or Asian websites called Alibaba, AliExpress, and so on, where you can get it quite cheap. But there's also German electronics websites where you can get it for almost twice as much. But yeah, it depends on where you want to get it. Yeah, but
Okay, good.
Yeah.
So there is a description how to do this. Great. Yeah, I might actually consider it for smart homes at home. It's nice to know the. Do you also do consumption, like electric, water consumption? Is this also a use case?
I think they're happy of every new use case joining the community. As far as I know, right now it's pretty focused on air quality, so fine dust and dioxide, monodioxide, and but also the noise is getting more and more data, and of course radiation. And it just depends on what your personal use case is. If you are living near a train station or airport, you're more interested in noise maybe than in radiation. So, but yeah, sure. Everything which goes into the network is welcome.
So radiation is radon, or
yes.
Okay. I was wondering what exactly are you measuring. So radon gas levels, huh? Yeah. Good.
Maybe one last word. It's of course there's a lot of discussion about the quality of each instrument, yeah, and but the pure statistics of these many instruments is something very nice to investigate. Of course, it's not that good as a 10-20,000 euro expensive sensor which is attached by the government, but we have a very large statistics which is almost as good as an expensive sensor.
Yeah, I think they do these co-located studies, right? So you have, that there's an expensive sensor in a location, and you have a bunch of cheaper sensors, and then you can see how well they perform. And there are these studies. Shoban also has a question. A sensor would be great. Can we get them in Australia?
Yeah, I can help. You can get it from everywhere in the world. We have I have a connection to a Japanese project where we also support by getting these sensors to overcome maybe any restrictions by the university or border issues. So we can support as good as possible.
Great. Good. I don't see any other question. Then I'd like to thank Sven for the presentation, also in the repeat session. Thanks for joining. And
thanks for giving the opportunity.
Thank you. And then I would move to the recordings. So let me see if we can get this going here. So the next presentation is by Martin Fenner, and he will give us a quick update, a very brief update on what happens within DataSite. Remember that one of our approaches is with DataSite, so the implementation of the schema is with DataSite, and we have identified in the alignment of the PIDINST schema with the DataSite schema, we have had a few points that would be great to extend the data schema with, so that we can accommodate sensors more easily. And they are working on this, and Martin will tell us a little bit what's the state here. So let me just share the screen, and then I will play here the audio and video.
Right, Rolf, that I have about 3 minutes, or just a quick update on integrating instruments in the DOI schema, right? And the very short version is that DataSite DOI metadata schemas are updated about every year and a half. And the last update was 3 weeks ago. And we had an agenda that we finished, which is mostly about text documents and sort of starting now. We are working on the next metadata update, and that includes better support for instruments. And because the RDA group has done a lot of work, the wish list is very short, and it seems very straightforward. It's just that updating metadata schema always takes time, and there are sort of details to sort out, and that's why that probably means that it's maybe about a year away before this is sort of the official DataSite DOI schema. And maybe as a refresher, what the group has worked on and sort of decided. The most important one is adding instruments to the controlled vocabulary of what DataSite calls resource type general. I think there was a small discussion about instrument, whether that's a good term or whether people get confused with musical instruments, but I think that's not really a big issue. Most of the other issues were around sort of documenting how to use the schema for instruments, and also sort of small name changes. So what a DataSite metadata is typically called a title, that for the instrument name would be better. And we can do this with something called title type. I don't want to go through everything, but I would say there is not really anything that the group wants that's super complicated. And I think it's just the work of updating the metadata schema, also do other things in the next metadata schema release. And it just so happens that one of the co-chairs of this RDA group is also a member of the Dataset Metadata Working Group. The reason that he's not on this call, Ted Haberman, is simply because he lives in Colorado, and that's not really the time to sit in front of a screen and give a presentation or do a discussion. So maybe rather than continue in some of the details there, are there any feedback or comments, for example, that since the original document was created about dataset metadata, whether there are any significant changes, or should we just work through this and then when there's details, just have a discussion?
Yeah, so I guess we will come to that in the discussion round at the end of the session. But there's one question I would like to ask. First of all, what you told us is good news. I'm very glad to hear that. And there's one immediate question that I would like to raise is, when can we expect that these changes become, let's say, official? Do we have a rough estimate?
A rough estimate is beginning next year.
Okay.
And as you, for example, have done, the changes are so minor that, of course, you can use the current schema. And there, for example, resource that general doesn't exist, but resource type is free text. So, if you cannot wait, you can use the schema now and then update once these changes are official. But I think a year is realistically, and don't ask why it takes a year. It's mostly because it's other things that also go in the same release.
No, I can confirm on that. So we already used DataSite DOIs for some of our instruments. We will continue to do so. And we will then, when the schema changes become official, we will then update our PIDs later on. So that was just, so we have a few of these very short, say, lightning interventions at the beginning. And so the next question would be, is Ulrich Schwartmann?
So, yes, this was the presentation by Martin. So I stop here before I move to Ulrich, because maybe we can get back to the live session here and see if there are any questions from the participants today. Good. The chat is relatively quiet. I think we are a small group. You can just also speak up if you have something to ask. I think we are just probably 20 people or so here today. So that would be fine, I think. Good. So then we can look forward to the DataSite changes in a year, as we heard from Martin. I have a quick poll maybe to the participants. Is there anybody in the room that can envision to use DataSite DOIs to identify instruments today, or better to wait until the changes are implemented? And so in a year, anyone could imagine doing so? +1 in the chat would be enough. Yes, Rolf. Yeah, you are known candidate. Because if we can identify, yeah, okay, Jens, great, in the next month, 6 months, so that would be even before the changes. So obviously people think that the current approach is at least mature enough to give it a go, and then see, I mean, as you know, you can change the metadata schema later on, so you can adapt. Unless you have millions of instruments, that might be a little more challenging. You have to do it programmatically perhaps, but Otherwise, you can always change the metadata later on and adapt it with the new changes. Some of the community probably, so I suppose that that's the Australian community that Shoban is leading, the I for iOS. Good. With this, then, if there are no more questions, then I would about the changes, I guess that's Christian. Yes. So the changes are a little bit documented on the GitHub. And maybe Rolf, meanwhile, you could post the GitHub URL if you have a chance to do that. There we have listed the changes there that would be great to have. But as Martin said, it's relatively minor things, and that can be done relatively easily. So introduce a type for instruments, which currently is missing in the control vocabulary and things like this. Research infrastructure, the whole platform, PID. Okay. So the whole platform, so for the whole research infrastructure identifier, that's, I think, the question from Marie-Claude. Yeah, that's a slightly different case here. So for persistent identification of instruments, you would use then for the individual some of the parts of the research infrastructure. So that's a complex system, social technical, well, depending on you see it's only technical anyway, but it has, of course, also instruments, many. And the PIDINST schema would apply best to the instruments, not necessarily even to platforms or sites that the research infrastructure might have. And I don't think it's a schema that is designed for the identification of an infrastructure, for a research infrastructure. Now, I'm thinking about the European definition of cyber infrastructure, or in other parts of the world they are called a little bit differently. So for the research infrastructure itself, this would have to be taught a little bit whether it's fitting. Good.
I would add, so for research infrastructures, so if this is an organization, then of course it would fit in as owner to the instrument PID. So this is where you could link the instrument with infrastructure.
Yes. Good point. Maybe you could even think about assigning the research organization identifier, the ROR, to the research infrastructure, and then use this as a mechanism to link the things. I think there's a debate a little bit what if a research infrastructure in the organization and so on, but I've had quite a bit of discussions there. But yeah, that would be one thing to consider indeed. Okay, then you can still continue on the chat. I will get back to this. I will then move to Ulrich Schwarmann's talk and do the same thing again.
Okay, fine. Then
just play the video. So here we go.
I need to go there. Okay. Types versus linked data is something which is actually, from a certain point of view, it's quite easy. You have a PID and you have key value pairs also stored in the PID database, and together this gives actually a triple, a subject predicate object triple. Example is you have is next version of, and you have a PID that is the next version of another PID, and obviously this is a triple. And this is next version of is a type which is then defined in a data type registry, and has again via this approach has again a PID. So at the end you have a triple of three digital objects. One is the subject, the PID itself. The other is a type which has a PID, and the third is the object, which is the old version, for instance. And what we have with the instruments, PID for instruments, we have records like that. This is a very short one. It's also only in a part of the bigger one. We have minted at the National Oceanography Center, and but because we want to explain how this actually works, it's better to use such a simple one. And we have there actually two type definitions. One is a name, and the other is owners, which is an array of possible owners. And inside the owner, we have, for instance, an owner name and an owner contact. And if we would transform this into the PID descriptions for types, actually all these have its own type description. So the owner name, for instance, also has a type description, and this already looks very much like some turtle expression. There are the original IDs are missing currently, but you can see already that this is strongly related to the linked data approach. And on the other hand, you see in the bottom the expression of this PID as a PID, or yeah, as you see there, as a possible expression where you have a URL, you have two types, and you have a admin record which describes who has which rights to change this PID. And what of course you have to do now, you have to go deeper into these types to actually finally come up with a JSON LD representation, which again is similar to this approach or this description we have had at the beginning, where you not see these awkward PIDs, but the real names. And this is actually done by going deeper into the data type registry, find out how the definitions are, which names are used there, and so on. So this is the JSON LD description of that. And there is already, and I'll show this in a short online session in a few minutes, or in just 1 minute, how this actually works with a REST interface. What you can see there is it's possible from PID with types to get a JSON LD, but also the other way around. From a JSON LD, in principle, you can create PIDs with types from this, because it's a one-to-one relation. And one has to, first of all, create the most lowest types in these type definitions, and you go hierarchically to the top at the end. But important is, of course, for this you only get valid records if the values inside these key value pairs are valid with respect to the type definitions. And this also means that if you have such a a automated approach, then you can validate whether the type definitions are correct. And if you use a not invalid description, then you get an error. And therefore, this possible use of a REST interface is also a kind of a validator. Also important, this also can be used in the context of PIDs that provide valid metadata types and with a defined profile. So if you know where the metadata is and how this metadata has to be shaped, then you can also use this approach, in principle at least. Currently, this is not implemented in this REST interface. And you have some additional advantages. All references in this linked data description have a long-term perspective because they are PIDs, and this goes down into the leaves to the lowest parts in the description. You have a hierarchical structure of the type intrinsically or already in its definition. So you already know more about what the linked data actually is from the type description itself. And so you have already a reusable reusable part in these types. This does not only apply to single instances. What I'm going now is I would now share another screen, and this would be the live demo, which is almost the end of this. You see here a web browser and now making this REST call. And what you see now, it's going very deep into this data type registry. And at the end, the whole record will be provided. And you see here all these definitions which are done. And then you see also the whole context part, which is quite a lot of different definitions inside the type registry. So this would be what I have to present. And I would hand back to Rolf.
Yeah, thank you very much. That was very interesting. And I guess we will hear more about that in the future. But these interventions at the beginning are just considered as lightnings. So we switch over to the next.
Great. Yeah, I didn't hear this in the previous session, so it's great to hear this now because Rolf Ulrich is not here by any chance. No, because I would wonder whether they plan based on this some Sparkle or GraphQL endpoint also. That would be quite interesting to have. Are there any quick questions? I'm not sure I can answer it, but we can try. Otherwise, please get back to Ulrich Schwarman and good. I don't see anything in the chat, so I suppose there are no questions. Then, also in the interest of time, I would move to Mark. Again, we have a video recording from the last session about PIDINST and an effort at EUDAT in collaboration with DataCite and EPIC also. So, Mark, the floor is yours.
I don't think Mark is present. You need to play the recording.
Sorry?
Mark is not in the session. You need to play the recording from Mark.
I need to play. So you don't see it, or?
No.
I'm confused. Is this so? This is not the recording from Mark, or?
For the moment, we don't see anything.
You don't see anything. Okay.
You didn't share.
Why is it off? No. Strange. Okay, sorry about that. I thought that I was still. So now you should see the screen again. Okay. So let me go back then. So
I'm Mark van der Zanden, and I'm from EUDAT as technical coordinator, and this is an update on the B2N service, where it is a collaboration between DataSite, Epic, and EUDAT. And the focus of B2Inst is to provide a registry for instruments, where users can register the metadata on instruments, and after registration they will get a PID, DOI for the registration of their instrument. The first step is just a recap of what has also presented at the last plenary, is an update of what the service is. This is a screenshot of the B2Inst website, and it is based. The B2Inst service is based on the B2Share technology, and we have updated and modified this so that we can support the PID for instruments metadata, and that you can log in and do the registration of an instrument within this. While you register an instrument, then you have to provide a name, you need to provide a description, you need to provide the metadata of the instrument, of course, and you will get a PID, and we register a DOI for the instrument, but also we register a PID within the Epic domain. But next to having the basic information which you can do registering the metadata of an instrument, you can also do versioning of the metadata. If something changes, then you can update the registration to a new version, but also then you will get a new PID for that new version, but you can maintain the same PID for the landing page of your instrument. We also provide the option that you can add additional resources to your instrument. For example, if you want to upload a picture of the instrument or maybe a user manual, then you can upload this kind of information to the record of the instrument, and it is fully maintained, collected to each other. Also, each upload which you do of a document or a file will get its own PID where you can refer to. We also support within the service the concept of community domains, and community domains is a separation of the basic definition of the metadata or the community domain, while you can also within the community you can provide extensions to the metadata. Because if you look at the use cases which are provided within the working group, there are many different communities which have instruments, but they also have different additions which they would like to see or require to describe their instruments. And this is possible within the community domain, because there we can support extensions to the root schema which we provide. This is an overview of possible community domains, but you can also, within the community domain, define next to the extensions to the metadata, also providing criteria of how instruments can be published. Can anyone publish instruments within your community, or do you want to have more a publishing review process implemented so that you limit the users who can upload instruments, or that, for example, before instruments are being published, that there is a review of one of the community data managers to see if this instrument is allowed to be published within the community domain. So we provide a lot of flexibility, I think, towards communities to shape how instruments can be registered or be published. For the B2Share or the B2Inst service, we also provide an API. So if you have a lot of instruments, you can also automate the process of the registration of those instruments within the service. But you can also collect the metadata again. So if you want to display it in a different way, you can read the metadata of an instrument within your community domain and display this within your own service, or you integrate this within your workflows which you have for using the metadata of the instruments. I want to thank Maggie and M3Fair because they had set up a training session for PID for instruments, and they used the service, the proof of concept service which you had, so that they can learn to see, okay, how do you register instruments? How do you use PIDs for instruments? And for us, it was very interesting to learn if the service which we were setting up, how users would look at the service and how they would use the service. And they provided us very good feedback on this, which we can take up in the further developments of setting up the service. Some general feedback. A very good starting point. It was about 50-50%, quite useful or could be useful. There were also some tips to better understand, okay, providing information on what kind of information should be filled in. And that's certainly one of the things which we have to address, because I noticed that if you look at the record and you move across the key values, then you get information, but when you are filling in the records, then we are missing some descriptive information of what should be provided on the fields which should be filled in. So we have to improve this so that it is really understandable what you have to fill in. There were some fields which are providing also a free text, which they remarked that it would be better to have a controlled vocabulary for those fields. But then also, again, I think because there is a diversity of kind of fields which can be provided, then you have to work with the community to more define what is this field meaning for this community, so that you can adapt this to the description of how the community wants to use this. When we set up the metadata, we also looked at of course, to the PID schema of the RDA working group, but we saw that still we made some mistakes in defining the schema, so we have to update the schema so that it is fully matching at the root the schema of the PID working group. Also, we got a comment on the registration procedure. In general, everyone could register, but there were some comments that the registration procedure of getting an account on the system could be improved. And was also another general comment that if you have a lot of instruments, and certainly in the environment community, they have a lot of instruments, then probably they see that, okay, that will be done more within their own community domain to register those instruments. They have their own service for doing this, or their own databases for registering, but it could be useful for some smaller research groups which are not really capable or do not have the focus on maintaining such a service by themselves. So therefore this can be offered as an external service to them to maintain metadata for the instruments. Going further, there was some feedback also via tables and percentages, and I really want to collect this information because it is very helpful for us. If you so the overall view was that it was quite useful, could be useful. but also if you look at what the information was about registered instruments, easy to interpret, there it was clear that we have to improve on this, and that is providing more information, more descriptive information. I think there also within the working group we can work on this to see, so can we improve the metadata so that what is described of the keys and the values is more descriptive, so that we can integrate this within the descriptions of the service. It was easy to start up with the service, start registering. Is the form of the registration instrument easy to use? In general, it is yes, but there are also some comments that people find it difficult. Probably that has also to do with the interpretation of the descriptive information, what you have to provide. And I think that is also somewhat related to the Q10 question. Was the available help tooltips adequate? So that was not sufficient. So that should be certainly improved. Then finally was, would we consider the B2 in service when it comes operational? Large part, yes, but also some are saying no. And I can imagine certainly if you look at the larger communities and if you look at some of the members of this working group, they're already working on doing the registration of these instruments within their own database, within their own environment. So therefore, it is about mainly focusing at users and communities which have not yet such a service, but are thinking about doing the registration of instruments in the future. What are the next steps? We are moving forward towards from a proof of concept to a production service. We found GWG as a service providing partner who is currently setting up the service. We are going to provide a production asset, but also a training asset, because as you can see, for example, with Fair, they want to use also those kind of services as a tool for training, but you do not want to populate training information with production information. Therefore, we want to set up two different instances. We have to define the terms of use and the service level agreement for providing the service, so that users are also know what they can expect from the service. We have to fully comply with the PIDINST metadata schema, so there will be some revision work, and at our side in adapting the schema. The community extensions, so I think it will be very interesting to work with a number of communities to see what kind of extensions are they require on top of the basic metadata schema, so that they can better describe their instruments for the community domain. We work with DataSite for the DOI registration. We work for Epic for the PD registration, but also for going forward to setting up the production instance, we're also waiting on the beta share version 3 technology, which is planned before the summer. And that has some improvements on the whole service, and that is what we want to use for the production instance. This is the update. Thank you. And any questions?
I thank you. So
in two places. Thank you, Shoban. So back to the live session. Any questions, quick questions in the chat? What happened? Rolf?
no, I just wanted to say if we need to proceed.
Yeah, otherwise, that's right. I would then move to Louise, certainly also because she didn't have the chance the last time.
Hi, my name's Louise Darrick. I'm from the British Oceanographic Data Centre, BODC, at the National Oceanography Centre in the UK. And today I'm going to talk to you about links between sensors, platforms, and instrument PIDs. this topic of capturing rich metadata associated to sensor instances has come up a few times in our PIDINST monthly meetings recently, and I wanted to show you how we were doing this at BODC operationally. So our metadata for sensors is stored in a relational database. The database was constructed to match metadata to sensor data in near real time. It contains sensors from a variety of platforms. So we have the Apex floats, we have the underwater gliders, which are essentially these underwater aeroplanes, autonomous underwater vehicles, so unmanned submarines, and static moorings. So these are essentially wires hung in the ocean with arrays of sensors on them. We've got 38 metadata tables, all in Oracle, and they're complemented by audit trail tables. So we have a history of any changes that have actually been made to the database. So our database was designed to actually publish the sensors as web resources. So we're using the Sensor Web Enablement Sensor ML standard. And with a bit of content negotiation, you can also get the Semantic Sensor Network Ontology standard as well, so the SSN ontology. This provides the RDF linked data version of the web resource. So how do we structure these linkages? So our sensor instances are actually described as configurations of model designs. We also link our sensors to their data, and we're using the observations and measurements convention from 52 North. We also link our sensors to instances of processes, so details of the actual data processing that was done to the data. We link our sensors to a history of events. So these can be things like calibration, maintenance, decommissioning. And then of course sensors get deployed. So we link them to deployments. And then of course the sensor is deployed on a platform. So we have platform instances as well. So in this particular case, we've got one of these underwater flying aeroplanes. Platform instances are also linked to configurations of their model design. We link our sensors to their orientation. So this is the X, Y, Z coordinates of the sensor on a coordinate reference system of the platform. And then we also link our sensors to campaigns, so funding information and location. And this is done through the deployment. In addition to all of these linkages, we also link our sensors to even more metadata. So we link it to, for example, its capabilities, something like a detection limit. We link it to its characteristics, what's its weight, what's its housing material, manufacturers, contacts, what's it actually outputting, serial number, model number. So how do we use instrument PIDs in such linking? Well, at the moment, our sensor instances are actually identified using a local ID, a local UUID, we call it. And this is actually shown in the red box. The problem is that the ID doesn't mean much to anybody outside the organization. So to facilitate its discovery and to enable aggregation with other sensor nodes, we want to actually use that UUID as a suffix in globally persistent identifiers. And we've actually demonstrated that we can do this using the EPIC handle system. So the right-hand image shows an instrument PID that we've created for one of our sensor web resources. The green box shows the URL of the web resource, so it actually shows the URL of the sensor. And in this particular example, I actually let the handle system generate the suffix. So it's a random set of numbers in the blue box. However, going forward, we want to actually specify our UUID. So we hope to make this operational in the next year, and this will be in a project called iOcean. And this will involve taking near real-time data from the fixed sensor arrays from 3 of our UK research vessels. Thank you.
You are again muted.
Sorry. Yeah, I was just saying that IO is a great project name. It's a great catch there. Unless there are any questions, I would then move to Anu's presentation quickly.
Hi everyone,
yes.
my name is Anu Surya Devaraju. I am Data Innovation Manager of TERN. TERN is Terrestrial Ecosystem Research Network in Australia. Today I'm going to talk about the mapping between our model, data model, which is called TERN Ontology, and the PID metadata schema developed by the working group. Next slide, please. So this is the outline of my presentation. I will first give an overview of the two underlying model. One is the PID metadata schema, and the other is SOSA SSN ontology. So the TERN ontology is primarily developed based on the SOSA SSN ontology. Then I'll give you some descriptions about the research infrastructure, the instruments that part of the infrastructure, and finally the outcome of the mapping. Next, please. Okay, so the PIDINST metadata schema was developed to support the registration of scientific instruments using persistent identifiers. At present, the schema comes in two variants. So the first is the original schema. This was developed using a bottom-up approach where the use cases are collected from institutions operating who are interested in registering their instrument with PIDs, and from there they use the use case requirement to identify common properties. And the second release is a result of mapping the original schema with the data side metadata schema. So my mapping primarily used the original schema. Currently, both schema is available as a documentation, which can be potentially translated, for example, to XML schema. Next, please. So this is an overview of the original metadata schema. As I'm not going to in detail here because some the previous talk already talked some of these properties. Next, please. So the SSN SOSA ontology, SSN stands for Semantic Sensor Network Ontology, and SOSA is a sensor observation, sample, and actuator ontology. This ontology is our W3C recommendation. The goal of the SSN SOSA ontology is to represent sensor and observation and related concepts, for example, procedure, property, feature observed, sampling activity, and so on. This is an ontology which is available in RDF serialization, for example, Turtle. Next, please. So this is an overview of the SOSA SSN ontology. So the SOSA is actually provide core minimum classes and property for the SSN. So the green, the boxes in green indicate the core classes from SOSA, whereas the blue classes and relations are from SSN. So as you can see, for example, the sensor use a particular procedure to make a certain observation, which is an activity. And this observation is carried out upon a feature of interest that carry an observable property, and the observation activity produce a result. So this is the overall, let's say, the overall core concept of the SOSA ontology. Next, please. So now I will introduce about the research infrastructure and also instruments. Next. So TERN is a research infrastructure. As part of the infrastructure, we have instruments, we have a data related to terrestrial, starting from the continental scale. For example, remote sensing data up to regional scale, which is ecological plot observation, and finally local scale. For example, flux observation, phenocam, acoustic sensor, and so on. Next. So our information model or ontology is based on SOSAR. However, we have adapted that that ontology to fit the requirement for modeling terrestrial ecological data. For example, to capture information about sites, site visits, and so on. For more information, you can visit the link. The ontology specification is available online. In addition to the ontology, we also have a terminology services, which we call as a TERN link data services. So where we actually use to create different vocabulary that can be used to express values, for example, methods, parameter, and so on. Next. So I'll give some example of the mapping based on the flux monitoring towers and the instrument mounted on the towers. For example, as you can see on the left side, this is a tower, is a platform, and on the platform there are several instruments of sensor. On the right side of the diagram, you can see that this particular flux monitoring tower, which is called Culperum, and it hosts several instruments, and each instrument have metadata like make, which is referred to the manufacturer, the model, and the situation here is referred to the height where the sensor is deployed on the tower. Next. So this is an overview of the simplified overview of the TERN. How, as you can see here, all the classes starting with prefix TERN refer to the TERN, and we actually extend the classes from the SOSA ontology. So this is an example. As you see, Alice Mulga is a supersite, and this site hosts a flux tower, which is Alice Spring Mulga flux tower. And part of this flux tower, it hosts different sensors. Example of sensor is a sonic anemometer, and this anemometer measure properties such as wind direction and wind speed. Next, please. So now I'm going to give a summary of the mapping between the TERN ontology and the PIDINST metadata original schema with focus on our platform and instrument information. Next, please. So I just include if you want to know more information about the mapping, you can access the Excel sheet provided here. So basically, for each of the property, we try to identify what are the relevant classes of property that are applicable to the metadata property specified in the PIDINST schema. Next. So this is some summary of the mapping coming from the mapping. So in general, all the mandatory property specified in the PIDINST original metadata schema are actually covered in the TERN ontology. with the exception to the property called landing page. The landing page, in the context of the landing page is trivial because we manage our own namespace. We are not registering the instrument with other PID provider. Therefore, the landing page is not captured as part of our model because all the flux towers and the site are identified by PID, and that PID always resolves to the landing page maintained by our system. The second aspect is that in the original schema, the type of the identifier depend on the PID provider. So for example, in the case of Turn, we are using W3ID identifier. So so as part of the future work, it's good to use the control list provided by the dataset schema, which already include W3ID as one of the identifier types. And in the original schema, that is the properties are classified based on like manufacturer owner, whereas in our model we use the concept called roles. A person or organization can play a role. So example or role are like a site PI or owner or funder. So we use the concept called role to represent the function that can be played by an organization and person, and this provide flexibility to represent different roles that are associated with the instrument management and operation. Next. In the PID, in the PIDINST schema, there are some optional property. For example, manufacturer models are identifier and identifier type for manufacturer and model. In our implementation, this information is represented at a cost level, so we only capture the name. We don't assign identifier to the manufacturer or model. And the next one, the last comment is that in future or in near future, if somebody want to adopt or adapt the PIDINST schema, let's say to set up a instrument catalog, then we feel this metadata information is relevant to be incorporated into the schema, because this is like these are important for operation and management of flux instruments. For example, the relation between the site, the platform, and the instruments. The location, currently the original schema, there is no locations, so it's good to have some possibility to represent location that can be a geographical location or toponym, for example, especially if the instruments are in the lab. And also deployment context. For example, it is important in the case of flux to know the height where the instrument is deployed on the flux tower. So these are the information which are currently being captured as part of our ontology, which we think is relevant if someone wants to adapt the PIDINST schema to have more in-depth information about instruments. Thank you.
Let me unmute this time. Great. Good. Thank you, Anu. And we have essentially 50 minutes left. So I would like to have a little bit of a round, or at least ask if there are any questions. And if there are no questions, perhaps Shoban, you would want to take a little bit of time to also discuss I4IOS, and maybe we can have a chat on, yes. Assuming the microphone works this time. Shoban, we cannot hear you yet. It's Friday. Okay. Yes, great. So any questions, and maybe a minute for Shoban to sort the microphone out. if this doesn't work, then we can go back to the original plan. I just wanted to give 10 minutes also to Shoban, since she didn't have the chance last time due to technical issues. Yes, Shoban, we still cannot hear you, and Patricia has a hint in the chat. You can choose the source in the fourth button. Yes. Yeah, now we can hear you.
Oh, I can't
Not
hear.
see you, but that's okay. Yes, we can hear you.
How's that? No luck?
Yeah, it works.
How about this one?
Yeah, it works. We can hear you.
Oh, Patricia, you can hear me?
Yes.
Oh, great. Can everyone hear me? Oh, fabulous.
Can you hear me?
Well, okay. I can't hear you though. We can't have everyone.
Okay.
I'll just really quickly say a little bit. So I facilitate the I4I Oz group in Australasia, and that's identifies for instruments. So we've watched with great interest and support what's happening with the PIDINST group, and working towards a schema that can get as wide an acceptance as possible. So something we've talked about recently is the need to get use cases from across lots of different disciplines. And it's really difficult to do that because we are an area of persistent identifiers that is very much dealing with sensors, and it's very much dealing with the scientific community. And we raised that we'd really like to see more use cases prior to the push for wider adoption for the schema. So I think maybe the discussion to be had here is how can we get those use cases? We know we need them and we invite them, but it seems like we haven't got the communication going into those areas to get those use cases yet. So I wonder if we can talk, maybe not now, but more later on, about how we can get those use cases coming in to be looking at things happening in humanities, the GLAM sector, and make sure that they're included in the development of the schema. There's a danger that we have the schema come out and people see it as whole and fully formed for every case that's going to be out there, when really it hasn't had that wider cross-disciplinary exposure, not through any desire for that to happen, but just because it's difficult to get those use cases from other areas. So yeah, we're really keen to find out people's ideas about how we can get more of those use cases and to help them feed back into any further developments in the schema. Really interesting to see the work that's happening there, particularly with the data sites schema. I think that's great. That's really a great direction to be going in as well. So yeah, that's from myself as representing I4I Oz at the moment. There's probably a few other members from us floating around in this time zone as well. Thanks very much for giving me a moment, Marcus.
Sure. Can you hear me now? Yes. Okay. So Shoban as well, or okay, but some of you anyway can hear me. So my question back to you directly, Shoban. I hope you can hear me. Otherwise, I can type it in chat. If you have some of these communities represented in I4I Oz, that will be a channel to get some connections.
Currently, I don't think we have any. It seems like if I have a microphone, I can't hear you. Sorry. So wave and I'll click my buttons. we've got maybe some representation through some of the universities that are representing. I'm thinking particularly of University of Auckland, who have some interesting things happening in archaeology, and also through ARDC co-investment projects. One in particular is about a language commons, and we're looking at some of that discussion is about what is an instrument as well, I guess, because it's very easy to say, oh, the sensor is definitely an instrument, but is something that helps us look at, natural language tracking. Is that an instrument, or are we talking about software? Sometimes it's a difficult decision to have. So we do have a few little inroads into these other areas, but not as much as we'd like, and we are still finding it difficult to get members from those areas.
Okay, yeah, so this would have been my first approach to see whether you have had contact. The other thing is, of course, within RDA to more strongly reach out to, social science, humanities. I think there are some groups looking at the research data in that context, those disciplines. So we could more, actively reach out to these groups, and I guess that's one way. So we had a definition of the instrument measuring instruments. We aligned a little bit to this to what was it called? This Institute for Measurement. I don't remember the name, but they have a definition of measuring instrument, and usually we aligned it with some process implementation of some process of measurement, and as a result of this, having some digital data. So I think this can be extended to also not or devices a little bit more broadly. Yeah? So I had also suggested the idea that a questionnaire could be an instrument, and usually these questionnaires in the end eventually lead to measurement data, also digital data. So I think I'm not sure that there will be a lot of issues there, but yeah, it will be, I agree, interesting to discuss. And of course, then not just whether the notion of instrument applies, but also whether the metadata that we came up is sensible in this context. Yes, Rolf.
Yeah, I guess in order to discuss whether something is an instrument or not, I believe we would need to have practical examples. So it goes back to what Joban suggested. We would need use cases from that area, and would need to know what is the thing that they want to identify, and what are the properties of that thing, and whether it fits into the concept or not.
Yeah, so
it's difficult to discuss that in the abstract level. We would need to have practical examples. Absolutely,
yeah. So we would definitely need to collect, and in a similar way as we did with the other use cases, we had these templates. I would then, if we identify a community, let's say in social sciences or so, might be easier first than, I don't know, philosophers. But we could then reach out and suggest that they could fill out some of these templates that we had, or the template that we had for the metadata that they need, for instance, for a questionnaire. But I guess prior to that, we really need to identify some people, representatives of communities. And maybe we can scan through the RDA groups and look whether there is a suitable community in social science, and then reach out to the co-chairs there and see what they think about this. Maybe it's not relevant, maybe they haven't been thinking about it. So it's obvious that I'm not surprised that, for instance, the earth sciences are, let's say, represented very well here, because they just have a lot of these physical things, and they think in instruments in classical term. But yeah, so maybe these other communities, they just haven't been giving this a lot of thought. But yeah, let's try to reach out to them. It's I think a good idea. And yes, Rolf.
As a practical suggestion on how to proceed, so the next scheduled group meeting, monthly meeting, would be the 5th of May. And that would be Australia-friendly time. And Schoban, if you can make it to that meeting, we could basically dedicate that monthly meeting to discussing on how to proceed with that.
Yeah, I already discussed this also with Schoban. Yes.
Down to the end, that would be great. I'm really happy to help with helping this proceed. Thank you.
Great. So thank you, Schoban. Hope it was enough time for you to share these thoughts. Unfortunately, we are already running out. We have 50 seconds. So if apologies to Steve Collins. So I opted this time to give Schoban a little bit of space at the cost of Steve's presentation. Any final questions? I didn't see anything in the chat, so I suppose people are happy. But if you have some final question, I guess we can also stay a little bit longer. So those who have to drop out, thank you very much for joining today. I hope you enjoyed RDA. Have a good rest of the day and also a good weekend. And well, the next RDA is around the corner. So see you soon again and stay safe.